systems, mainly we saw signals. So in signals, we saw what is a signal, discrete time signal and continuous time signal, elementary signal like sinusoidal signal, exponential signals, sinusoidal signal and exponential, unit step function, signum function, unit ramp function, regular rectangular pulse or gate function, unit impulse function, representation of impulse functions, properties of impulse functions, unit impulse train, unit rectangle function, and so on. So you have seen a lot of signals, then time shifting, time scaling, time reversal, all of this. And then we have seen odd and even signal, periodic, non-periodic signal, all those. Today we are going to start with system. So what is a system? A system is processes input signals to produce output signals. So in a system, input signals come, the system processes the input signal and outputs a signal. A system is combination of elements that manipulates one or more signals to accomplish a function and produces some output. So a system is a combination of elements that manipulates one or some signals, one or more signals to accomplish a function and produces some output. That means a system actually takes an input and produces an output. Internally, it manipulates the signal for its purpose to output necessary signal. Examples of systems: a circuit involving a capacitor can be viewed as a system that transports the source voltage signal to the voltage across the capacitor. Okay, I think you can understand this. This is a simple thing. A communication system is generally composed of three subsystems: the transmitter, the channel, and the receiver. The channel typically attenuates and adds noise to the transmitted signal, which must be processed by the receiver. Biomedical system resulting in biomedical signal system, control signal system. Okay. One system example is the RL circuit. So here Vt is the voltage, R is a resistor, and L is the inductance. So using the first order equation, VLT equal to L di dt. So Vt equal to VR plus VLT equal to IR plus L di dt. Okay. Most continuous time systems represent how continuous signals are transformed by the differential equations. For example, RC circuit dVC dt plus 1 by RC VC dt is equal to 1 by RC Vs dt. Vs 1 by RC Vst. System indicating car velocity m dv dt plus rho Vt equal to Ft. Mathematical modeling of discrete time systems. So you can see that basically a continuous time system can be modeled by linear differential equations. Sometimes it can be nonlinear also, or it can be partial differential equations also. But generally it is linear function and it is differential equation. Linear differential equations are used. For example, in RL circuit, you can see that the equation is IR plus L di dt. In RC circuit, it is dv dt plus 1 by RC Vt plus 1 is equal to 1 by RC Vs. Okay. Now, discrete time systems, most discrete time systems represent how discrete signals are transformed by difference equations. Bank account, discrete car velocity, etc. etc. So yn equal to 1.01 yn minus 1 plus xn. That means there is a 1% increase in the previous year plus the deposit that is done in the current year. Bn minus m by m plus rho delta Bn minus 1 is equal to delta m plus rho delta Fn. So this is mathematical, this is discrete time systems. which is represented by difference equations in case of discrete time systems. Order of system, the order of a continuous system is the highest power of the derivative associated with the output in the differential equation. For example, so among the differential equation, the highest power of the derivative associated with the output of the differential equation is called the order of the system. So, for example, m dv dt plus rho vt equal to ft. In this equation, the order of the system is 1 because the output signal's highest power of the derivative is 1. Order of a discrete time system is the highest number in the difference equation by which the output is delayed. For example, the order of the system shown in 1 is yn equal to 1.01 yn minus 1 plus xn. Here the delay is 1 because yn minus 1 is there. Okay. Can you tell me what is the order of the system of the second equation? Yes?
So 1.
1, right. Why?
Because the highest order is also over here also is 1 only, sir. It's like single difference.
A single difference is okay, but here the delay is
Like
counted. No, here in discrete time system, the highest number in the difference equation by which the output is delayed. So yn to yn minus 1, yn minus 1 is the maximum delay. If it were yn minus 2, then the order would have been 2. So here the difference is the delay is n minus 1, d b n minus 1. That's why the difference the order of the system is 1. This is the delay of this equation. Last one. What is the order?
Sir, also 1, sir. 1, sir.
Why? What
So
is the
the
output
highest
signal?
derivative is 1 only, sir. Is of
No,
order
no.
1 only, sir.
I'm telling what is the output signal?
Oh.
Yes or BC?
Sir, VS, sir. VS, sir.
Yes. So what is the order? 0. Right? No difference, so
Yes.
the output will be 0. Okay. Now interconnected systems can be parallel, serial, cascaded, or feedback. Okay. So VT is connected with a resistor, a capacitor, and two inductors in parallel. So xt is equal to yt equal to txt, x0t, x2t, x3t plus and x0t, x2t, then in multiplication. This is the interconnected system's equations. So interconnected system consider the following system with 4 subsystems. Each subsystem transforms its input signal. The result will be y3 is the result. Y3 will be equal to y1 plus y2 and y4 will be equal to t3 times y3, that is equal to t3 times t1 xt plus t, and yt equal to y4t into y5t equal to t3 into t1. Are you getting this? Yes. This is the interconnected system example. Wherever there is a plus, there is an addition of signals. Whenever there is a multiplication, there is a multiplication of signals, and the square boxes represent transformation by 1, 2, T1, T2, etc. etc. Are you getting my point?
Yes, sir.
Okay. So the output will be yt equal to T3 T1 xt plus T2 xt into T4 xt. Feedback system. Look here, there is a feedback from the output back to the xt. So here et equal to xt minus y3t. Tell me what is et here? Yes?
Sir,
Et,
ET is like a attenuated signal, sir.
yes,
Output
yes,
signal.
but I want to know what is its value in terms of x and y.
Xt minus y3t.
Yes, so what is xt is xt and y3t is?
Sir, T. Sir, T3 yt.
T3yt. Then go back. Yt equal to T2 mt. Is that right?
Yes, sir.
Yes.
That means it is T2 T1 ET. Yt equal to T2 T1 ET, right?
Yes,
Yes,
sir.
sir.
That means Yt equal to T2 T1 xt minus Y3t equal to T2 T1 xt minus T3 Yt, which is equal to T2 T1 xt minus T3 Yt. So Yt is a function of itself, Yt, right?
Yes, sir.
So you can actually do a rearrange of terms and you can find the equation, right? What is Yt? Okay, there are different types of systems like causal system, anti-causal system, linear system, nonlinear system, time variant system, time invariant system, stable, unstable, static, dynamic, invertible, and inverse systems. Okay, causal and anti-causal system. Causal system, a system is said to be causal if the present value of the output signal depends only on the present and or past values of the input signal. Example, yn equal to xn plus 1 by 2x, 1 by 2xn minus 1. Is this a causal system? Yes?
Yes, sir. Yes, sir.
Why?
Sir, because the values of like after the on the second iteration, the first iteration's value of controller 1, plant 2, and sensor 3 will affect the value of y3t and consequently the value of et in the next iteration, sir.
So is it a causal system? Causal
Yes, sir.
system means it only depends on the input signals past and present values. So
Sir, it does not depend on the input signals past and present values, sir.
yes, it is depending on input signals values only, right?
Yes, sir.
So it is a causal system, right? Because yt
Yes.
can be represented in terms of xt, right?
Yes, sir.
Hmm. Okay. Anti-causal system, a system is said to be anti-causal if the present value of the output signal depends on the future input signal. Example, yn equal to xn plus 1 by 2x in minus 1. So see, the current value of y depends on the future value of x, which is xn plus 1. This is an anti-causal system. Linear and nonlinear system. A system is said to be linear if it satisfies the principle of superposition. For checking the linear superposition, what is the principle of superposition? Yes?
Sir, could you repeat the question, sir? Actually, my network went down actually.
What is the principle of superposition?
Sir, if two different uh, if two different stimuli come into one system, the net result is the sum of both of their effects individually, like combine their individual outputs.
Right. This is superposition means it will be added. It will not be multiplied, it will be added. For checking the linearity of the given system, firstly we check the response due to linear combination of inputs. Then we combine two outputs linearly in the same manner as the inputs are combined, and again total response is checked. If the response in steps 2 and steps 3 are 3, system is linear, otherwise it is non-linear. So for checking nonlinearity of a given system, what we do? Firstly, the response due to the linear combination of inputs is checked. Then we combine two outputs linearly in the same manner as the inputs are combined, and again the total response is checked. If the response in steps 2 and 3 are same, the system is linear, otherwise it is non-linear. Is it clear? Yes?
Yes.
Okay. Time variant and time invariant. The system is said to be time invariant if a time delay or time advance of the input signal leads to an identical time shift in the output signal. A system is said to be time invariant if a time delay or time advance of the input signal leads to an identical time shift in the output signal. For example, yit is equal to hxt minus 1, t minus t0, which is equal to hst0 xt equal to hst0 xt y0 t is equal to hst0 yt. And did you understand this? If there is a shift in the input, then the corresponding shift in the output will occur. Okay?
So,
Stable and unstable system we will do next class. But let me tell, is this a time invariant or variant system?
so for example, so we can check it. So I'm just telling the methods. I'm not really sure about the answer. Like yn plus h will be equal to x n plus h plus 1 plus half x n plus h minus 1.
Yes, so is that correct in this case?
Mm. So it's giving the same shift, sir. Like both sides are shifting by h only, sir.
Right, so it is a time
Time,
invariant system.
yes, sir.
Is this a causal system? Causal system means current output will depend on the previous past present of the input.
Yes,
So
sir.
it is a causal system, right?
Yes, sir. Yes, sir. Yes, sir.
Okay, can you write the equation for this circuit? VTRCLL. Draw an equation for write an equation for this circuit. Everybody. Anybody done?
Sir, I'm a little confused about the inductor part, sir. Like, how will I factor that in?
Why?
So the L's, sir, because the L's are feeding back to VT, which is
Yes.
the input signal.
Yes.
So, so will there be sums like L1T plus L2T feeding back into VT, and
No.
therefore it,
L1, L2T will depend on capacitor.
and L1T will depend on resistor.
Yes. The voltage across L1T is equal to VT minus IR.
Yes, sir.
Anybody could do it? Anybody? Are everybody doing it?
Yes, sir. We're doing it, sir.
Where are others?
Yes, sir, doing it, sir.
Tell me what is the result? What is the output? Somebody Okay, review it from your class 12 physics book. I am leaving today. Next class is tomorrow from 1:30. Okay? Is it okay?
Okay, sir.
Yes, sir.
Okay. Is it done
Okay, sir.
now? Could you do
Yes.
it? Yes?
Yes, sir.
Okay, tell me. Tell me. Yes? Okay, so see you next class. See you next class. Revise the part. Revise this part from class 12
Sir,
physics book.
will we get the notes for this, sir? Because we didn't get the notes for these errors yet, sir.
This I've sent already.
So on our mails or in the files?
I send it to the CR.
Okay, sir. So we didn't receive it as of yet, sir. That's why we don't know.
Talk to her. Talk to her. Shankita,
So
I
you
think.
sent it to Sankita, sir. So you sent it to
Yes.
Sankita.
Yes.
Okay, sir.
Yes.
Okay, sir. So we'll ask her, sir.
Okay. 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 I'm leaving. Next class tomorrow. 1:30.
Thank you, sir.
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 Guys, I have it in my mail. I'll forward it soon. Okay?
हाँ ठीक है
हाँ ठीक है चलो.
चलो ठीक है